Hey, welcome to our presentation. I'm James DeMarco, and I'm joined by Marcus Yu. Together we are the Orange team, and we just want to give you a bit of an introduction to ourselves and some of the business ideas that we are considering for the course. So, as I said, my name is James DeMarco. I'm entering my junior year in computer engineering. I'm also starting my master's for engineering management through R². Outside of academics, I run track and field. I specialize in hurdles and sprints. I also like to play guitar, where I play like acoustic and country style music a lot. Now, in my free time outside of my internship, I'm working on an RF telemetry system where I can send data from a plane or a drone that has like acceleration and gyroscope and GPS down to a ground station so that it can be displayed onto a laptop.
Hello, my name is Marcus Yu, and I'm a class of 2028 mechanical engineering major. Climbing is really important to me. I've been climbing for just about 10 years now and competing for 7. I'm the Rose-Hulman climbing team manager, and for the past 2 years, I was able to represent Rose on the national stage at the USA Climbing Collegiate National Championships. And last summer, I began developing somewhat of a novelty product that they call the PCB rule. As a kid, I had this bright red DigiKey ruler that I thought was so cool, and when I learned about what a slide rule was, I thought it would be awesome to make one out of PCB material. And so last summer, I finally acted on that idea, and it was my first foray into product development, and I realized for the first time that there's a lot of work that goes into creating and selling a product. As part of our team building, we did a this or that activity where we asked each other questions such as coffee or tea, cats or dogs, morning versus night person, and beaches or mountains. We spent a few minutes each responding to these questions as well as giving brief response, brief explanation. We thought this gave each other a pretty good glimpse into the kind of people our partners were, and it was a pretty good informal way of getting to know each other. On the more serious side, we also went through each question on the team building document on the Moodle. We discussed each question and the scenarios, and we wrote down answers as we agreed upon them. Without further ado, let's introduce the business ideas. So our first idea is a digital finger strength training system designed for rock climbers. Finger strength is one of the biggest limiting factors in climbing performance, but it's also one of the easiest areas to injure. Current training methods don't provide precise measurements of finger strength, which makes it difficult to know how hard somebody should be training. Our idea is a digital load cell device that measures finger force directly. This allows climbers to train closer to the maximum strength while reducing the risk of overloading tendons and ligaments.
So our second business idea is a smart inventory tracking system. So right now, most warehouses use a manual system where they have to manually scan individual barcodes or RF tags, right? And the issue here is that most of the time, items are going to slip through the cracks, and that's going to cause companies to lose time and money because they have to send someone in to go fix that. So our solution is to automate the process using RFID scanners and sensors to detect changes in inventory. That way, all this can happen behind the scenes instead of having to waste a worker.
Our final idea is a smart beehive management system. The problem we're trying to solve is that collecting data from beehives becomes extremely labor-intensive once an apiary grows beyond about 10 hives. Beekeepers often need to manually check temperatures, hive weights, and other indicators of colony health. Our solution is a wireless, solar-powered monitoring system that continuously records these metrics and sends them to a central hub. The goal isn't just to automate data collection, but to make hive management easier, more reliable, and accessible for both hobbyists and commercial beekeepers. So let's dive a little bit into our first idea and explain the concept a little more. Finger strength develops differently than muscle strength. While muscles can adapt in a matter of weeks, tendons and ligaments often take 6 months to a year to strengthen. Because of that mismatch, finger injuries are extremely common in climbing. Most climbers currently train using hangboards or weighted crimp blocks, but those methods only allow for adjustments in fairly large weight increments, usually 5, sometimes 2.5 pounds. Our concept replaces those rough estimates with direct isometric force measurements, giving climbers precise feedback about exactly how much load they're applying and allowing training intensity to be adjusted much more safely. So there are actually devices out there already designed to do this sort of thing. So why aren't more climbers using digital force sensor devices? Products like the Tindeck exist, but they're designed for individual athletes. They connect to a phone through Bluetooth and are meant to be carried around by one user. We think there's an opportunity in commercial climbing gyms. Instead of a portable device, we envision a permanently installed training station with an integrated display that anyone can walk up to and use. No phone pairing, no account setup, and no borrowing equipment from a front desk. To validate this idea, I spoke with the gym manager at the Center One climbing gym location I'm working at this summer. One concern Art raised was that portable devices are difficult to loan out because they're expensive and can be easily lost or stolen. Many gyms would probably have to hold on to a member's driver's license or credit card as collateral before letting them use the device. That conversation reinforced our idea that a fixed installation is much better suited for commercial gyms. It removes the inconvenience for both the gym and its members while making the technology much more accessible. Today, these kinds of systems are mostly available only to serious climbers who are willing to spend several $100s on their own equipment. Our goal is to make this technology available to everyone by placing it in climbing gyms where it can be shared by hundreds of users. By making objective strength testing more accessible, we believe climbers can train more effectively, reduce injury risk, and track their progress with much greater precision than current training methods allow. Our monetization strategy for this product focuses on commercial climbing gyms rather than individual climbers. The primary revenue stream would be selling complete training stations directly to gyms. Since the system would be permanently installed, it becomes part of the gym's equipment instead of something members have to borrow or purchase themselves. Beyond the initial hardware sale, we can offer optional software features aimed at individuals who wish to take their training a step further, such as member accounts, progress tracking, workout templates, and analytics through a subscription. This creates a recurring source of revenue while giving climbing gyms a unique training tool that helps attract and retain members.
All right, so let's sketch out the RFID inventory system. So currently warehouses are still tracking inventory manually, one scan at a time. This is a very painstaking process because workers have to be assigned large amount of times to take inventory every couple of weeks, or they have to scan codes manually, which is affecting productivity levels, right? Our solution is compelling because we can automate this process and make it very accessible to small and mid-sized warehouses that would only require maybe one or two RFID sensors. Now let's analyze the market. So the warehouse industry is very stable. We're always going to need somewhere to put our stuff. That means that bringing a new product to this market would have long-lasting opportunity and very high potential growth. Now, in recent years, the cost of RFID tags have dropped enough so that they can be used in bulk applications such as an inventory system. Again, RFID is not a new technology in itself, but using it for inventory is new, and specifically using it for automatic inventory is something that is brand new. So this is a wave that we can get on right now. All right, so let's look at development. Now remember, today's warehouses manually scan items one by one to update inventory. This is a process that is slow and very error prone. Now, our product's job is to give distributors confidence in what they have and where it is, without having to send someone to physically check every single time. This will give distributors real-time visibility into their entire inventory all in one place. Now, before, this process would take at least one worker, and it would take multiple hours, in some cases even multiple days. Now it can happen all in the background with no active workers. This will save companies time and money that's lost through either errors or just plain inefficiency through using a manual system. All right, so let's talk about monetization. Now, this is a relatively simple process. There would be an initial cost for installation and setup of all of the RFID sensors and training for the employees on how to use the system. In addition to that, there would be a monthly subscription that companies can choose for shipments of tags based on inventory size. Then part of that subscription would be some sort of maintenance where we can provide a worker to fix any sort of issues that the company could run into. We also do have a kind of a main barrier of entry is some upfront capital to kind of get the ball rolling. Since the sensors are the most expensive part, we would need to get the first couple of customers started. Now, what is the customer saying? So recently I talked to Jerry Schulman, who is the owner of Texas Toys Distribution, and he told me that it absolutely seems ideal for warehouses that primarily handle bulk distribution. Now, the reason for that is handling bulk distribution is less tags overall because it's not as many individual items. Less tags means a less noisy environment. Overall, it's just cheapest for that kind of distribution. However, this management is still applicable to all type of warehouses. It's just that there's different price points for different types and different inventory contexts. Now, on the other hand, Andy Hendricks, who is the partner at Hendricks & Company, he is skeptical, right? He says that the benefits sound very tempting, but he's skeptical because none of his peers are using RFID right now. So all this tells me is that customers the only reason that they're not looking at RFID inventory tracking is that they don't trust it. So if we can build a product that is trustful, then we would have no problem getting this off the shelves.
Now let's dive a little bit deeper into our last concept. Our smart beehive management system is designed to give beekeepers continuous insight into the health of their colonies without requiring constant manual inspection. By automatically collecting and logging data from every hive, beekeepers can identify trends, detect potential problems early, and make more informed management decisions. Our concept consists of one monitoring unit installed on each hive that communicates wirelessly with the central ground station. Each hive measures metrics like weight and internal temperature, and in the future could also monitor entrance activity using computer vision or radar-based sensors. Unlike existing systems, we also want the ground station to incorporate its own weather station. This allows beekeepers to directly compare changes in hive behavior with the local environment using real-time weather data collected right at the apiary, rather than relying on weather stations that may be several miles away. Another key design decision is using solar power wherever possible. Many commercial systems rely on battery-powered probes that require frequent maintenance. By harvesting solar energy and minimizing battery replacements, we can reduce maintenance while making the system much more practical for larger apiaries with dozens of hives. Our main competitor is the broodminder system, which is widely used by researchers and commercial beekeepers. While it's a capable product, we identified several pain points from actual users. First, the sensors rely heavily on batteries that require frequent replacement. Second, many advanced features require ongoing subscription fees. And finally, future development is limited because the system is proprietary. Our goal is to build an open source alternative that removes these barriers while adding features that existing commercial systems don't currently offer. Our customer feedback comes directly from a real user. My mom is a master beekeeper with the UC Southern California Research and Extension Center, which currently manages 22 instrumented hives using the broodminder system. Her biggest complaint is battery maintenance. Each hive requires multiple battery-powered probes, so across the apiary they're replacing several batteries every week. She also mentioned that comparing hive activity with local weather data would be extremely valuable, and that accessing information on a smartphone while wearing gloves and a bee suit is inconvenient. Those comments directly influence several of our design decisions. Our business is built around an open source hardware and software platform. Instead of charging recurring software subscriptions, we generate revenue through hardware and services. We believe an open source approach makes sense because much of the required hardware already exists as off-the-shelf components. Load cells, thermistors, weather station sensors, and LoRa radios are all readily available. For software, we plan to build upon Klipper. Although it's known as a 3D printer firmware, it already includes many of the capabilities we need, such as sensor logging, networking, remote management, webcams, and data visualization. Other open source communities, like the Guinos Espresso Machine project, have already demonstrated how flexible the Klipper ecosystem can be by applying the open source framework built by Klipper developers to non-3D printer applications. Let's talk about monetization. The first revenue stream is DIY parts kits. There may be hobbyists out there interested in building their own Hive Manager system. Anyone that's ever tried to tackle an open source hardware project before knows how daunting it can be to open a bill of materials spreadsheet and see parts from 30 plus manufacturers and sources. To remove this headache, we would source all the electronics, sensors, and components and sell them at a slight markup. The second option is fully assembled plug-and-play systems for customers who want minimal installation work. These offerings will be aimed at those with less than 25 hives, all located near each other. And finally, we can offer enterprise solutions for large farms and vineyards, which often have multiple groups of hives spread around a sprawling property. These complex systems may require multiple hub stations. It can include custom system design, installation, and optional maintenance contracts. Because the application is variable, the customers would need to obtain a quote for pricing. Compared to the existing broodminder platform, our system aims to expand functionality while remaining open and customizable. Beyond standard measurements like hive weight and temperature, we'd like to add integrated weather stations, physical displays mounted directly on the hive, solar power, and future options like computer vision or radar for monitoring bee traffic. Since the project is open source, the community can continue adding new features over time instead of relying on a single company for development. For the finger strength training system, we thought that the concept has potential and it identified a real niche existing within the current market for communal, non-portable digital strength training system. However, we thought that the development potential was limited, and because of the commercial customer audience of the product, we failed to see a straightforward path to a consistent revenue stream.
So now let's take a quick glance back at the RFID system. So for the pluses columns, we chose concept sketch and development. The main reasons for those is that the need for a system like this is very clear, and the ability for us to provide a solution to that need is also very clear. Now, in terms of the market analysis and monetization, we gave both of those zeros or evens, mainly because it is still hard to penetrate this industry, and our monetization depends on trust from the consumer that we can provide a reliable system.
The Smart Beehive management system checks most of the boxes. The current market offerings are limited in functionality and locks the customer into a hardware investment which is rendered useless without the support of the company. The open source aspect reduces the development load on the founding company. Essentially, all we have to do is create the framework to implement basic features meeting or exceeding the capabilities of current offerings and give beekeepers a platform to build off of. Because the business itself exists primarily as a hardware company, we think this concept lacks a robust monetization strategy. For the non-enterprise customers, there's no element of recurring charges or income. I think the open source nature of this offering is an essential benefit and differentiator of the system compared to the competitors, so I'm not sure that we should compromise on this aspect. Finally, let's review some strengths and weaknesses of our ideas. For the digital climbing system, some strengths are that it provides accessibility to digital finger strength training systems to the average climber, and it reduces the chance of injury, especially for beginning climbers. Some weakness is that it adds complexity to training, and its intended use has to be done within a shared facility with the system installed.
So to sum up the strengths and weaknesses of the RFID system, essentially we're looking at the fact that for strengths, automatic tracking is faster and it's less prone to human error. And additionally, RFID tags have dropped in price. In terms of weaknesses, the sensors are still going to be very expensive. And it's really more applicable for small and mid-sized warehouses, as those will require less sensors.
For the Smart Beehive management system, some strengths are that its open source model allows tech-savvy beekeepers to add features as they need them, and the low financial barrier to entry opens the technology up to hobbyists and not just farms or research facilities. Some weaknesses is that the monetization plan is less robust, and because there are no significant recurring charges, increases in revenue must come from new customers or old customers who expand the number of hives.
So last but not least, what are our next steps? So in order to get our 3 business ideas down to 1, we have decided to make a decision matrix where we have put a weight on each of the 4 categories that we presented on, plus a 5th category, which is based off of your feedback. Now, we will rate each business idea in their strength in each category on a scale from 0 to 5. Then we will weight that by multiplying it by the respective categories' weight. Then we will sum up each business idea, and that should hopefully give us some really good insight into the viability of the pursuit of each business idea for this class. That is all for our presentation. Thank you, and I'm looking forward to your feedback.